know, the image of f under R is not equal to R, thus f is not onto. More specifically, this calculation explicitly shows that 0 is not in the image, right? This shows 0 is not in the image of f, therefore f is not onto. You're like, well, why did you choose 0? I don't know, it's just a choice. I could have chose 2, right? I mean, you could make a lot of different choices to disprove onto there. The larger point here is when giving a counterexample, when showing something's not true, you need to give specific evidence, not a sort of general argument, all right? General arguments are not good for counterexamples, usually, especially in this class. This one, notice that f of 1 is that, and f of minus 1 is that. Of course, minus 1 is not equal to 1, therefore the function's not onto, right? All it takes is finding a specific pair. If you had given me, I set f of a equals f of b, and it works out, and I get a is equal to plus or minus b, that's lovely, but that's not a proof. Like, I need specific counterexamples, all right? So my standards for proving something's not one-to-one are higher in here than like in my pre-calculus class. Pre-calculus class, you set f of a equals f of b, you work it out, you get, b is equal to plus or minus a, and be like, yeah, all right, good for you. That's enough, all right? I'm just happy that you understood that there was a plus or minus when you took the square root, so. We're past that. This is Math 200, so, yeah. This one here is the one I was talking about where we actually have a proof that a function is a function, and the proof goes like this: n equals to 10, m equals to 5. At first, you notice the whiteout suspiciously there, because originally I thought that it was not a function. So there's like knots I've whited out, and I was like, oh man, it's a function. But I want to give up on this piece of paper because I've already written a good solution in the earlier part of it, so we must go on. And anyway. So what I do is I suppose we have x and y, two different representatives, mod 10. For equivalence class, we need to show that implies that 3 times x plus 1 and 3 times y plus 1, mod 5, both work out to the same animal. And as such, this means y is equal to x plus 10j. And so when what does it mean for this and that to be equal? It means that their difference has to be a multiple of what? Of 5. So when I work the difference out, I get 30j, which I can rewrite as 5 times 6j, which is tantamount to saying that, indeed, for different choices of representative, we get the same output. This proves it's single-valued, right? We've spent a lot of time disproving single-valuedness. This is how you prove single-valuedness. You need to show that the function's constant over all the possible representatives. In contrast, this one over here, you just oh, by the way, the thing I hadn't emphasized is, first of all, you need to check that it's actually a relation in the right sense, right? It has to have the right domain and the right codomain as advertised, but those things there's usually nothing to check there. It's just kind of immediate. In contrast, for part B, all I had to do was, notice that 0 is equal to 4, mod 4, and yet when I plug 0 or I plug 4 into the formula, I get different outputs. Therefore, its function's not the quote-unquote function. The relation, we should say, is not single-valued. All right. Anyway, sorry, I haven't talked much about induction today, right? But if we go back, what was the... find it eventually here. If we go back, I guess as long as I look at the first one and then look at the next one, then that's enough for today, right? Sorry, we're out of time, but anyway, so do go back and as always for my classes, I always encourage students to review the homework that's been assigned, right? For you guys, look back over the quizzes, study the classes examples that we did, and ask yourself the question as you're working through this, like, what would be a good test question? It could be sometimes, and don't just immediately discard difficult homework questions. Oftentimes, there's a subpart of a difficult homework question which I can extract to make a test question from, right? So just because the homework problem's impossible seemingly impossible, doesn't mean there's not a part of it which is worth learning from. But anyway, And if you guys have questions, you can come ask me. I will shut up last.